Welcome back. This week you have to read Exploration 3 and do the highlighting and add notes. So I wanted to kind of quickly go through it and show you what you should highlight. All right, what would happen if you were on a sandy beach and a strong wind blew towards you? Do you think that sand might blow on you? Winds carry many kinds of materials, including sand, as they move across the atmosphere. You can see some of these materials, such as the dust on a playground. Other materials are too small to be seen, such as water vapor molecules. Wind can carry materials thousands of kilometers over oceans and large areas of land. So I think that we got to get winds can carry many kinds of materials, including sand, as they move across the atmosphere. Also, I think I might want to get let's get thousands of kilometers. I mean, because the idea that it can move, a long ways, right? So that doesn't need to be a separate note. But remember, you got to paraphrase this now. So you would left click on it, add note, and you would say, let's see, let's write winds carry lots of materials, sometimes thousands of kilometers. Okay, and remember, always save and close. All right, so I'm going to kind of crank through the rest of this real fast, and if I go too fast, hey, pause it, back it up, watch it again. All right, moving air also transfers something else you cannot see: energy. When warm air moves over an area where the land or water is cooler, energy is transferred from the warmer air to the cooler water or land. This transfer of energy by wind is an important factor in Earth's weather. So actually, this section of this exploration is really nice because it kind of follows like a more predictable pattern. Pretty much like first and last sentences are the most important. So I'm going to kind of scroll past here real quick. All right, with these, together with a partner, discuss, and just skip those. Okay, I'd like you to do the drop-down menu ones and the like. All right, the cycling of matter in the atmosphere. So we've got, think about sand blowing on a beach. Wind picks up these particles of sand, moves them to a different place, and deposits them. Because of the small size of the sand particles, they can easily be moved by wind. Wind can move many other types of matter, both living and non-living. Some types are much larger or smaller than the sand particles. For example, a slight breeze will move only very light materials such as a feather, but a hurricane winds or tornado can move cars, cows, and other large objects. These movements are parts of the constant cycling of matter through the Earth system. So I'm going to want to get in this case, the second sentence. Okay, so we got them picking up particles. Oi, come on now. And we've got also the last sentence. I want to get these movements like so. Okay, all right, so probably a note for each of those. Moving right along. If you choose to answer this, you may. All right, water. Water, one of the components of air is water. Oh, you know what? Right away, that looks like something we should highlight. So I'm going to highlight that bugger. Okay, a material needed by every living organism. Water vapor enters the atmosphere from the Earth's surface. Then water in the atmosphere is carried by wind from one place to another, often hundreds of kilometers. Water falling from clouds in the form of precipitation is used by living organisms. It also flows across the Earth's surface, soaks into the ground, and forms rivers and lakes. Some of this water will enter the atmosphere once again. Water continuously cycles in the Earth's system. I think we want to get that last sentence here. So like I said, this is kind of a classic textbook section in the sense that usually like first and last sentences are often important. All right, carbon, nitrogen, and phosphorus. Other important substances that are cycled in the atmosphere are carbon, nitrogen, and phosphorus. Well, that looks like something we should get right there. Okay, plants use carbon in the form of carbon dioxide during photosynthesis. You and other organisms release carbon dioxide during cellular respiration. Carbon dioxide enters the atmosphere when fossil fuels burn or when volcanoes erupt. Nitrogen is also released in the atmosphere when fossil fuels burn, during industrial processes, and when bacteria break down organic matter. Plants use nitrogen to make molecules called proteins. Oh, I see an italicized word there, so I'm going to get that. Okay. All right. Animals use these molecules to build body structures. Living organisms also use the element of phosphorus. As organisms excrete waste or die and decompose, phosphorus is released into soil and water. Water and wind can help cycle phosphorus through the Earth system. So maybe we'll get that last little bit there. Okay. All right. Moving right along. Organic matter. The atmosphere is also part of the cycling of organic matter and debris. Some living things, such as bacteria and the remains of once living organisms, can be carried by wind. The same is true for debris, such as ash or pollutants. Like most things carried by wind, you cannot see many of these materials unless they form a dense enough cloud. Let's get that first sentence. Oop, I didn't do a good job there. Okay, like so. All right. This looks like one we can answer, this cloud one. That'd be kind of fun to look through, but you look through that. Discuss, you don't have to bother with that. All right, so now we're flow of energy in the Earth's atmosphere. Matter is not the only thing that flows through Earth's atmosphere. Energy also flows through Earth's atmosphere and into and out of the Earth subsystem. I think I already got that earlier at the very beginning. Okay, but let's look at thermal energy. Thermal energy is an energy we sometimes think of as heat. It is the energy of a substance has because of the motion of its particles in the substance. Almost all energy on Earth comes directly or indirectly from the sun. Solar energy travels through space to Earth in a process called radiation. Radiation is the transfer of energy by waves, such as light waves from the sun. When the sun's energy is absorbed by Earth's surface, the surface becomes warmer than the air above it, and some particles of air collide with the surface particles, and thermal energy is transferred from the warmer surface particles to the cooler air particles. That transfer of energy when particles touch and transfer energy is called conduction. As air particles warm, the particles move farther apart, become less dense, and begin to rise. The flow of air due to differences in density is an example of convection. Convection can also be thought of as the transfer of energy due to the movement of matter. All right, so first thing, we want to get that thermal energy right at the beginning. Let's just get it all the way, it has something to do with the moving bits inside a substance. Okay, and then we've got radiation, and it's italicized here, but I'm gonna get the one after it because it seems to define it. Okay, and highlight. Okay, and then we're gonna get the one on conduction down here. Transfer of energy, it happens because of touch, is called conduction. And finally, we're gonna get flow of air due to density. I'm just gonna get the last two sentences. Okay. So you're probably going to need about 3 notes there. So don't just be like, oh, just do one big note. All right. So we're on to transfer of kinetic energy. This is the last paragraph. In addition to the transfer of thermal energy in the Earth system, there are transfers of kinetic energy. Kinetic energy is the energy of motion. For example, the kinetic energy of wind is transferred to the ocean water and powers waves and surface currents. The kinetic energy of the wind also moves materials such as the sand in sand dunes and changes the Earth's surface. So let's get that definition. Kinetic energy is the energy of motion. Okay. And also let's get the kinetic energy, because this is like what the next thing is. We'll get kinetic energy of wind is transferred to ocean water. Should we get the rest? Yeah, let's get all the way to surface currents. All right. Okay. So like I said, maybe I went too fast, but you can always back it up, watch it again. So you've got the highlighting. You just need to go and make the notes for it, the paraphrasing. Don't forget to save and close. All right. Bye-bye.